Hello, my name is Kevin Pearies. I am a Senior Technical Sales Specialist with EXFO, and today we'll be covering the setup of the FTB 3932 optical loss test set. So here's what I have set up. I basically have an FTB 200 with an FTB 3932 module. Once you started up the unit, the compact toolbox will launch, and this is the screen that you'll see. So whatever module is populated will show up here. So I have the 3932 as well as the 7400E OTDR in this particular solution. So I'm going to go ahead and highlight the 3932, and then down in the bottom left, you'll see it's a multi-test module. We'll go ahead and hit start to launch the module. So before we start, it goes without saying that it's critically important that you inspect and clean all your connectors as needed, particularly for this test. Optical return loss is a very sensitive test, and so that's one of the tests we'll be covering today. And so it is critically important that you inspect and clean your connectors as needed. So once the multi-test module application is started, you'll see at the very top we have several different test suites or tabs that we can navigate through. In the very top left, we have the fast test module, which is where we'll be spending most of the time during this training. So this is the full suite of loss and reflection and distance testing. This next tab over here that we're actually in right now is the power meter. So this allows you to use the power meter or the external detector on the actual module to measure light levels. An ORL meter if you just want to test optical return loss. The source VFL if you want to generate a signal, or if you want to send one of the red flashing visible lights. Messaging, this does support text messaging, believe it or not. So you can communicate with the unit on the far end. And then the very last tab is just the results. And so again, we'll be spending most of the time in the fast test module. So one of the first things we want to do as soon as the application starts is to do a nulling of the electrical offsets if needed. So the 3930 is actually designed not to require offset nulling under normal operations, but you should perform it whenever there's environmental condition changes that are significant, or when measuring very low power values. So if you're testing something very short, then offset nulling does assist with this. So we'll walk through that here real quick. We'll go to the power meter tab here. You'll see in the bottom left it says nulling. So it is critically important that you put the cap on the power meter port on the module itself. And so on the actual power meter port, there's a screw-on cap that will block all light. It's important to put that on here. So I have the cap on my unit right now. And of course, I can tell that it's off based on these power values here. If it was off, I would probably pick up some ambient light. And so this number would probably be not down in the -60s. So with that cap on, I'm going to go and hit nulling and then let it do its offset null. So here's where it's telling me to put the protective cap on, then press OK. And so I'm going to go ahead and do that. And the nulling's in progress, and now it's done. It's as simple as that. So once we're done with the nulling, let's go ahead and set up the unit. So down in the bottom right here, you see the option to go to setup. We'll click onto that, and this is where you can set all of your options for the test. So if you want to test in feet, kilometers, miles, this is where you'll set it down here in the bottom. One of the cool things about the fast test unit, so the unit on the far end that we're testing to, you can either save to that unit or to both units. And so this is where you can select those options. So add results to this local unit or add it to the remote unit. And so this is actually a really cool feature that we have test results on both sides. This next tab here is a fast test. So this is where you can select what wavelengths you want to test. So in this particular test, we're going to test all three wavelengths, 1310, 1490, and 1550. But you can select whatever you'd like to test. So we can get in here under custom and add and remove whatever wavelengths we'd like. So in this case, we're just going to do all wavelengths. Now, compatibility mode. This is the FTB 3930. It works in conjunction with another 3930 or our handheld FOT 930 max tester. It can work with our previous generation of optical loss test set in the 920 and the 3920. So you can go into compatibility mode to do that. Now, of course, you'll lose some functionalities because the older unit didn't do distance measurement and the ORL wasn't incorporated into the test. And so there are some differences between the two. but you can test to one of those devices as needed. So the next option is the power meter. So the FTB 3930 and the FOT 930 have 40 calibrated wavelengths. So if you're in the power meter mode, just reading light levels, it can be a little difficult or a little time consuming to toggle through all 40 wavelengths. How often are you going to need to measure 840 nanometers, right? So you can deselect these and just have the ones that you use the most often selected. And so that way you don't have to scroll through all 40 wavelengths. And at the very bottom, you can see where you can actually add your own wavelength. So if there's something specific in between, you can add those wavelengths in, and then it'll offset to that. Under thresholds, this is where we can set up our pass-fail thresholds based on loss, ORL, those types of things. I typically leave these off, only because every job has specific thresholds, so I'd have to tweak this every time. But you can do this, particularly if you're testing a large count fiber and you know what the expected loss or threshold value should be. You can go ahead and input those in here. I'm going to leave this at none for the testing that we're doing today. And the last one down here is the results. So here's where you can set up some custom cable and job ID names, the prefix for the cable name, those types of things. And I'm just going to leave these right where they're at here. So once we have all of that set, we can go into setting up the actual fast test. So again, fast test is the full suite of testing. It's going to be the power meter test, or the loss test rather, the ORL test, and the distance measurement all at once. So we'll go ahead and hit fast test here, and then we'll begin that. All right, so the first thing we'll need to do is an ORL 0. And so ORL 0 is done in the ORL meter tab. So we'll click on that tab here. And so basically what optical return loss is, it's reflection that's intrinsically in the fiber and every connector from end to end, right? So it's the reflection from end to end. It's like span reflection. It's an optical return loss test. So we need to zero out the test jumper that we have plugged in. So if you look at the bottom of the screen on the left, you'll see that there's 3 types of references: ORL 0, ORL reference, and default ORL 0. So ORL 0 is a manual method for referencing. So with these units came a little brushed aluminum looking device. It's called a mandrel. And so basically what the mandrel allows you to do, it allows you to manually wrap the fiber jumper, the test jumper that you have coming out of the module. You will manually wrap that around the mandrel to cut out the reflection. And essentially what you're doing is you're isolating the connector that's on the actual module itself, and just measuring the reflection of that individual connector. So that connector is not going to be in the network, so we need to reference that connector out. And so by wrapping it with the mandrel, we're isolating that connector from the open of the test jumper and then zeroing out the reflection that we see. So right now I have the test jumper plugged in, and in a perfect fiber connection that's an open, so basically like a UPC connector, if I had an open UPC test jumper, I expect about 14.7 dB of reflection, and I have about 15.87 on this one. And so my jumper could be a little dirty, or my reference could be off, one or the other, right? So essentially, I have my test jumper plugged in, and so that's what it looks like there right now. I will take the fiber test jumper that's coming out of my module, and I will start wrapping it around the mandrel. So I'll start wrapping it around the mandrel, and I'm supposed to get about 10 wraps out of it. So let me go ahead and do that. And you're not going to damage a jumper. It's actually designed to do this. So as I start to wrap the jumper, so right now we're measuring the open basically. This open is contributing a fair amount of reflection. The lower this number, the more reflection there is. So as I wrap this jumper around the mandrel, we're starting to attenuate the fiber, which is reducing the reflection from the open. So we want to see this thing climb. And for a UPC connector, we expect somewhere in the mid to high 50s. And so I'm wrapping and wrapping. So I'm about at 10 now. And so I've got about 10 wraps out of it. And this is the reflection of that connector that's on the actual platform itself. So now that I know what this is, I can reference this value out. So I'll hit ORL 0. And this is where it tells me to do the 10 wraps. I'll hit OK, and then you'll see it cycle through the wavelengths, and it'll reference it all out. And once it's done, it'll take that number and then put it up there. So as I unwrap it, this is my open. We are now referenced using ORL 0. The next ORL reference is called ORL reference. If you click that, it'll say connect an ORL calibrated patch cord, 14.7 dB, to the unit, then press OK. So this is actually a connector that is designed for ORL calibration. So it's a special connector. Most folks don't have it. We sell it. So if you do have one of these, you would clean your connector, plug that in, hit OK to reference it out. In this case, we're not going to do that because I don't have one of these calibrated patch cords. This is not something that we typically see being done in the field. The very last one is default ORL 0. So in the factory, we basically took a fiber test jumper that was very clean. We plugged it into the unit, and then we referenced it out. We created a factory calibrated reference. So if you're fairly confident in the quality of your jumper, you can use default ORL 0. So default ORL 0 reverts the sensitivity back to the reference ORL that was taken at the factory during calibration. So you see this jumps up to 58. So this connector, when it was clean, fresh from the factory, the connector on the unit itself had a sensitivity of 58.47 dB. Over time and usage, the connector on the actual platform itself will start to wear. So you'll start losing some of the sensitivity, which is why we see a difference between 58 and 54, which is when I did the manual wrapping. And the reason why is probably the quality of my jumper, or it could have been the quality of the port on the unit. It's hard to say. So if you have a bad jumper or a bad port on the unit, this number doesn't climb very high. So if you were to do a manual wrap, like we did for the ORL 0, so I'm going to go ahead and start wrapping it. And if you wrap it and wrap it and wrap it, and this number doesn't climb up very high, so let's say it stops here at 27 or 28, this is an indication that you have a bad connection on the test port. It's either the jumper or the actual port on the module, or both. So the first thing you do is replace the jumper. Get a nice clean jumper, make sure everything's inspected and cleaned, terminate it, and if it's still not improving, obviously if you have a fiber inspection probe, you'll be able to see contamination, but if it's not improving, then it needs to come back to the factory. So if it doesn't climb very high, if this value stays fairly low, like in the 30s or lower, then you're in trouble. So I'm going to go ahead and keep wrapping this like we did for ORL 0, just so I can get my reference again. I'm going to wrap this sucker back up. So here we are. I'm pretty happy with this value. And I actually don't have a mandrel with me today. I'm actually using a number 2 pencil. A cheap little number 2 attenuator, as we used to call it when I was a tech. So I'm going to go ahead and hit ORL 0. I have my 10 wraps in already. And I am now re-referencing the unit again. So that is how you do an ORL reference. So at the very bottom here, you see where it says loopback reference. This is actually just a quick little shortcut to do the next step, which is referencing out for power. So if I were to hit this, you'll see a little dialog box that pops up that says connect a fiber between the port and the power meter, and then hit OK. I'm not going to do that in here. I'm going to do it in another screen, but this is just a quick shortcut to do the next step. And that next step is referencing out the power. So we've offset null the unit. We've set up our thresholds. We've referenced out ORL. Now we need to reference out for power. So we reference out the reflection of the connector. Now we need to reference out the loss of that connector. So to do that, we go to the Fast Test tab. So I select the Fast Test tab. So your 3 options are loopback, side-by-side, and no reference. So our first option is a loopback reference, and it's essentially that. You're looping the test set back onto itself. So most of our testing is going to be done out of the Fast Test port. So we'll have our test jumper plugged in there. In fact, we should still have it plugged in there from when we did the ORL 0. So the open end will take and plug into the power meter port on the module. And so that is the screw-on connector that we have the null cap on. So we'll put the appropriate connector on there, adapter, and then plug in the open of our test jumper. So basically we're looping back from the fast test port to the power meter port, right? And so once you have everything inspected and cleaned and plugged in, we'll go ahead and take reference. And so it'll run through at the 3 wavelengths and do a quick reference. When it's done, we get our reference. So you'll see here in the middle column, we have our 3 insertion loss for 1310, 1490, and 1550. So the beauty of the loopback reference is because you are looping the unit back onto itself, you don't have to have the 2 units together. So if you have one module or one FOT 930 at one location and the other one is, say, 100 kilometers away, this is a great way to have a good reference without bringing the 2 units together. So that's the beauty of loopback referencing. The next type of reference that we can do is called a side-by-side. So a side-by-side reference requires the 2 units to be brought together. And so the thing about side-by-side reference is it's slightly more accurate than loopback. So if you're testing very, very low loss and you want to have the best accuracy possible, then side-by-side is preferred. And so the 2 units must be brought together. So you'll have your test jumper plugged into both units coming out of the fast test port. So out of the fast test port with the test jumper, and then you'll have that test jumper, the open side of it, plugged into a bulkhead coupler, into some sort of a coupler, right? And then you will couple that to the other test jumper. So essentially you'll have 2 test sets, both of them with their own fiber test jumper coming out of the fast test port, plugged into a coupler. So they're coupled to each other. And that is a side-by-side reference. So I've gone ahead and set that up on my unit. I'll hit side-by-side and I'll take reference. And they're referencing out to each other. So side-by-side reference, again, gives you a little bit better accuracy. But of course, you have to bring the 2 units together. And this value is only valid for the test between the 2 units. And so here are the results for the side-by-side reference. And so what we're taking into account here is because we have a connector in the middle, so we basically have 2 test ports that we need to reference out, the length of the jumper, which is fairly negligible, and the actual connector in the middle, so that bulkhead connector. So we're actually referencing out 3 different connectors. And so here's the value that we have here. And so the very last option here is no reference. I don't recommend doing no reference. Basically, we take the factory calibrated reference that was used, and we use that. And so there's going to be some accuracy issues there. But honestly, you want to do loopback, you want to do side-by-side. So here's what we've done up to this point. We've nulled out the power meter. So we did offset nulling on that. We set up our settings for the configuration, units, any sort of thresholds if we wanted to input those. We referenced out for the ORL, and then we referenced out for power. And so we're good to go. Now that we have all that done, we essentially can start testing. Now I'm going to go ahead and select my reference type. Now, of course, in a real test, you wouldn't be doing both loopback and side-by-side. You would do one or the other. I just wanted to show you both methods. Just like with the ORL zeroing, we wouldn't use all 3. We would use one or the other, right? And so in this case here, we did an ORL 0 as our final ORL reference, which gave us this sensitivity. And then for fast test, I'm going to go ahead and do loopback, because loopback is typically what we see being used in most situations, just because of the convenience. And so over here on the right, this is how we're going to name our fibers. And so the fast test actually saves one actual trace file. Within that trace file will be all the traces or all the tests that were done. And so right now we're just going to keep it at default. This is how it's going to name. And so from here on out, all we have to do is start testing. So we'll go ahead and plug into our network that we're going to test and start getting some results. So we are now plugged into our network under test. I'm going to go ahead and start a test. So over here in the top right, you see where it says fast test. We'll go and hit that button. And this will start a test. And so essentially the beauty of this test solution is we're testing loss, and we're testing reflection, and we're testing distance, all in a few seconds bidirectionally. So we're getting both directions, which is incredibly powerful. So the unit on the far end is the great job to have. So that unit, basically all they need to do is everything that we've done up to this point, right? ORL referencing and power referencing, and that's it to a large degree, and then plug into the fiber under test. But whoever initiates the actual test becomes the A location and controls the test. The unit on the far end, all they do is inspect and clean connectors and switch ports. They go from one to the other to the other. So after the very first trace is completed, you will get a dialog box, a save as dialog box. This only happens the first time, and this is the actual trace file that is going to be saved. So you can give it whatever name you want, so preferably something identifiable. So I can get in here and type a name. I go backspace out of here and say, we'll say test demo 1. And it's going to save it as an OLTS, and this is the location that it saves to on the actual platform itself, right? So I'm going to go ahead and hit save, and we've saved that very first file. So now that is done, and we see that we have, under tested fibers, fast test 001, and over here to the right, the next test is going to be 002. So essentially all we do is we go to the next fiber, and then we hit fast test again. And just keep doing this over and over and over again until your testing is done. So looking here at the results, we see our A to B, B to A, the average loss, and then ORL from A, and then ORL from B. So we're seeing bidirectional information here. And then down here in the bottom, we see distance. So I have a very large, or a very long launch cable that I'm using, which is why we have some distance here. There's not going to be any events in here, so it's fairly boring. We're basically measuring connector loss to a very large degree here. The ORL is not near as good as I thought it would be. But again, this is a launch cable I've had for a while. In fact, I've had it for about 8 years. So it's probably a little scuffed. So I would expect it to have a little bit of a high reflection. In fact, I would really prefer the ORL to be quite a bit higher than this. Usually you want 27 dB or better, or 32 dB or better, depending on the network that you're testing. So I could probably try and clean the connectors to see if this improves. But honestly, with the launch cable that I'm using as my network under test, it is quite a bit used. And so I've been using it for years. So I don't expect that it'll improve much. But this gives you an idea. I mean, for training purposes, we're seeing results and we're interpreting them. And if you wanted to look at these results individually, you could. So in this case here, let's say that I did want to retest this. In fact, you know what? I'm going to go ahead and retest this so I can show you another thing that we can do, and that's editing and deleting results. Because I have within the setup, I have the test configuration configured in a way to automatically save after every test. And so if I were to hit fast test again, it would do another bidirectional test on fiber number 2, and then automatically populate the tested fiber, right? It does it automatically for you, which is very convenient. The downside is if you need to retest something, you're going to have those results already in there. So you'll have to roll the numbers back and retest. So let's say I wanted to retest number 2. Here, number 2, I would have to get back in here, change my suffix here to number 2, and then retest it. And so I'm going to show you what happens when you do that. So as soon as the test is done, we will see here on the tested fibers window, we will see an additional fast test 002, but in parentheses, we have 001 here. So it's just showing that there's a second one. So we actually have 2 of these now. This first one was the one that failed that we wanted to retest. And this second one is the retest. So you can see how that can add a little bit of confusion. So that's the downside of manually or automatically adding tested fibers. But you can get into the results here, and you'll see the different fibers that were tested. I can select one of these here, and I can either edit it or delete it. So if I were to get in here and highlight it, hit edit, see what the options are. You can rename it. You can add a comment. This is a failed connector, test number 1, if you wanted to keep it and just add a comment. Or you can delete it outright. And now it's gone. And if I wanted to clean this up, I can edit this to remove the parentheses. Hit OK. And then if I go back into the fast test, we'll see that we just have the 2 fibers under test here. Okay, so I went ahead and re-cleaned the fiber connections, and we'll see if it improved much at all. So we'll see what it looks like here. And it really didn't improve much at all. So we're not seeing a lot of loss, but we are seeing pretty high reflection. I don't like this. Like I said, 27 is usually what I like to be at. For OC192s, 10 gig systems, 27 dB is what's recommended by the ITU. And for video systems, we usually like 32 dB or better. So you have to refer to your internal documentation on what's a good value. But these are not good for sure. But again, this is training, so that's the beauty of it. So from here on out, all we're doing is we're testing and saving, testing and saving. So once we're done with the testing, so let's say we just needed to test 3 fibers, we can go and hit save, and it would save the results. So I'll go ahead and do that. We'll go and hit save. We'll see that it's now grayed out. So the file is saved. Now, one thing to keep in mind, when we shut this unit down and move it to a different location to do additional testing, this file is still going to be in here. It's persistent. So we're going to go over there and plug into fiber number 1 on the new test case, and we're going to keep adding to the existing fibers here. So we'll go to this new location. We'll hit fast test. So we're at a completely different location. It's going to keep adding tested fibers to this list because it's still on the exact same file. The same file is open. We saved it, is what we did. But we didn't actually create a new file test case. So you see, now we're at fast test number 4, which is not what we wanted. We wanted to start a whole new test. So in situations like that, this is when you need to close and create a new test case. So if I was going to be testing at a new location, I would go ahead and hit close here. It would close this out and start with a blank slate. So I'll go ahead and hit close just to show you that. And of course, I'm going to go ahead and resave it because I added that last one. And then now you see we have a blank slate again. So if I were to start a new test case at a new patch panel at a new location, I would do everything that I did up to this point and just hit fast test. It'll start a test at fiber 1 again. And when it's done, it'll populate the list. And just like the first time, it will ask us for a new file name. So there's our old file name that we saved. So I'll just stay at default here, cable number 2, and we're off and running again, testing. So now that we've done all of the testing, saved all of our results, now it's just a matter of managing data. So getting the test reports off of the module or the test platform. So I'm going to go ahead and close out the test application because I don't need to do any more testing. Everything from here on is basically administrative. So I can get into the file manager here over to the right. And there's several ways to get data off the units. These units have connectivity options, so you can literally open up a web browser, get into webmail, and email it out while you're there on the job site. You can use a USB stick, which is basically what I'm going to do now. We have some cloud options as well. So there's different options or ways to get data off the unit. Probably the most common is just to use a USB stick. So I have a USB stick plugged into this unit. And so I'm in the file manager. So at this point, it's like a Windows environment. So I'll click on OLTS because this is where it's saved to. And here are my test files, right? So test demo 1 is the one that we did today. So essentially, I can just highlight it. I can go to edit. I can go move or copy. I like to copy. I don't like to move anything until I know or have it in 2 locations. Because if I were to move it now to that USB stick, that's the only place this data lives. And if that USB stick gets lost or gets corrupted, then all your test data is gone. So I like to copy it and then make sure that I have a copy left on the platform and then one in hand that I'll deliver to engineering or to whomever. So let's go ahead and hit copy to folder. And then I'll select my removable drive. And I'll just copy it to the root folder here. Hit copy. And it's as simple as that. And that's it in a nutshell. That is testing with the FTB 3930 optical loss test set. So all the training up to this point, I've been showing the screen for the FTB 3932, primarily because the handheld units don't have remote connectivity options for streaming. So there's no easy way other than setting up a camera over the unit while I try and push buttons. It's very hard to do training that way. But we do have an offline tool that we created years and years ago that I thought would be useful just to show you what the interface looks like on the FOT 930. So everything that we talked about with the 3932 applies to the 930. The menu just looks differently. So how you reference it, all the steps required are exactly the same. So there's no difference between the two. So on the far end, I have a 930. So this is essentially what the 930 looks like. less cartoony, of course, right? But this is just like an offline training tool that we used at one time. So everything on the front is basically soft keys, and here's the interface. So again, everything that we talked about on 3930 solution is the same here. I mean, as far as all the test steps, right? So I can scroll through here, and we can see the different options that we have. So right now we're on the power meter. If I were to hit the menu button, a little menu window pops up, and then I can switch to whatever application. Of course, it's not touchscreen. So I would just scroll down, and everything that we did in that other unit will also be here. So setting up the fast test, the compatibility mode, the wavelengths, all of that stuff is here. It's just in a different location. So it's under menu. You just scroll down to it, right? So just work your way down. And so here's where we could set our auto naming, all of that stuff, right? So there's a cable ID name. It's all very similar to what we did earlier, just in a different location. And so if I want to set up the fast test, all I do is hit the fast test button down here. It's off the screen a little bit, but right down here, we have the fast test button. So if I go ahead and hit this button, that'll take us into the fast test. So I'm going to go ahead and step through the steps that we did with the 3930 just to show you how it's done on the FOT 930. So the first thing we want to do, of course, is the offset nulling. So I'll bring this down just a little bit so you can see the connectors. So, of course, we have a power meter port on the top here. So that power meter port, we need to put the null cap on to make sure that no light is entering the detector, right? And so just like in the other unit, this was done in the power meter menu. So we'll go to power meter, hit enter, then we're in here. So scroll to the right to setup, and then within the setup, if I scroll more to the right, we have nulling. Press F1 for nulling, and then it asks you to do all of this, and then we'll hit OK. And then it'll do the quick offset null. So now we need to do an ORL reference. So we'll go ahead and hit menu. We'll go down to the ORL meter, hit enter, and then you'll see your ORL options here. ORL 0, ORL reference, do your mandrel wrapping, whatnot, and reference off ORL. So just show you what that looks like. We'll hit ORL 0. It'll tell you to do the mandrel wrap. You hit OK, and then it'll do that. So now we've done offset nulling. We've done ORL zeroing, and now we need to do our power reference, so either loopback or side by side, right? We'll go and hit fast test, and we'll do the loopback reference for power. So if I hit up and down on the arrow keys here, you'll see we can highlight loopback or reference type. If I hit enter, you'll see our reference types here. So I'll go ahead and just do a loopback, and then hit take reference here, and we are now taking a reference. So now we've done everything up to this point. All we're doing is testing from here on out. If you're the remote unit, all you're doing is cleaning and inspecting fibers and changing ports every time you're done with a test. That's all you're doing on that end. If you're actually going to be running the test, you'll go ahead and start a test, and then it'll start testing. But that's what the other side looks like. A lot of the same steps, in fact, all of the same steps, just a different interface. So that's it. Optical loss testing with the FTB 3930 optical loss test set module and the FOT 930 handheld optical loss test set module. Really appreciate your time. If you need any support at all, you can always email EXFO at support@exfo.com. Thank you very much.